That's one thing. But in Antarctica, they can go back 650,000 years. This, incidentally, is the first time anybody outside of a small group of scientists has seen this image. This is the present day era, and that's the last ice age. Then it goes up. We're going back in time now, 650,000 years. That's the period of warming between the last two ice ages. That's the second and third ice age back, fourth, fifth, sixth, and seventh ice age back. Now, an important point. In all of this time, 650,000 years, the CO2 level has never gone above 300 parts per million. Now, as I said, they can also measure temperature. Here's what the temperature has been on our Earth. Now, one thing that kind of jumps out at you is, well, let me put it this way. If my classmate from the 6th grade that talked about Africa and South America were here, he would say, did they ever fit together? Most ridiculous thing I've ever heard. But they did, of course. And the relationship is actually very complicated, but there is one relationship that is far more powerful than all the others, and it is this. When there is more carbon dioxide, the temperature gets warmer because it traps more heat from the sun inside. In the parts of the United States that contain the modern cities of Cleveland, Detroit, New York, in the northern tier, this is the difference between a nice day and having a mile of ice over your head. Keep that in mind when you look at this fact. Carbon dioxide, having never gone above 300 parts per million, here is where CO2 is now. Way above where it's ever been as far back as this record will measure. Now, if you'll bear with me, I want to really emphasize this point. The crew here has tried to teach me how to use this contraption here, so if I don't kill myself, I'll... It's already right here. Look how far above the natural cycle this is, and we've done that. But ladies and gentlemen, in the next 50 years, really in less than 50 years, it's going to continue to go up. When some of these children who are here are my age, here's what it's going to be in less than 50 years. You've heard of off the charts. Within less than 50 years, it'll be here. There's not a single fact or date or number that's been used to make this up that's in any controversy. The so-called skeptics look at this and they say, so? That seems perfectly okay. Well, again, if on the temperature side, if this much on the cold side is a mile of ice over our heads, what would that much on the warm side be? Ultimately, this is really not a political issue so much as a moral issue. If we allow that to happen, it is deeply unethical.
We're going to discuss the evidence for the relationship between the increased concentration of greenhouse gases and global warming. So this is a very, very well-known graph, and it's constantly updated with new data, which shows essentially the parts per million of carbon dioxide in the atmosphere since we started taking measurements in the 1950s. So we actually have direct measurements since then using equipment. So we can see that's a very, very steady increase. And if we were to look at another graph but we all know that average temperature has risen since the 1950s by 1 degree Celsius worldwide. So there's been a correlation, and when we think about the nature of science, we often try to see, are there any correlations? And yes, there is in this case. Now, also in An Inconvenient Truth, during the scene where he sort of hops on this, I guess, lift, and then it shows, you know, this big spike of where CO2 is now relative to the last over 400,000 years. So before that, obviously, we couldn't take direct measurements, but we actually have pockets of atmosphere trapped in the ice core. And when we take out those sort of bubbles of gas, we're actually able to analyze the isotopes inside them. And the isotopes inside them will actually tell us how warm the planet was. And essentially that's because when it's warmer, heavier isotopes can end up moving towards the poles than when it's colder and when they have less energy. If they have less energy, they tend to precipitate out closer to the equator. So again, you can see here on the same axes the temperature and CO2, the average temperature and CO2's concentrations have a correlation here. But again, the most important thing in science is that a correlation is, you know, a good thing to help you feel like you need to investigate something, but you really need to establish causation. And there is causation here because we have verified that CO2 is a greenhouse gas, and therefore it will cause more energy to be trapped on the planet, and thus increase temperature. Now there's a couple other things we should note. So the first one here, why does CO2 concentration go up and down? So in this graph, the red is the actual measurement throughout the year. It goes up and down, and the black is just the average. Now the reason that happens is because most of the vegetation on the planet is actually in the northern hemisphere, and very little of it is in the southern atmosphere. And so what happens is when it's winter in the northern hemisphere and there's a lot less photosynthesis as a result, CO2 will go up because there's not as much photosynthesis taking the CO2 out of the air. And then when it gets to summertime and there's a whole bunch of vegetation growing, then it's going to suck up the CO2 and it makes it go down. So it's a seasonal change of up and down, winter, summer, due to the unequal distribution. Now, a good question here, and this is one that he glosses over in the movie An Inconvenient Truth, and it's one that climate deniers like to bring up as evidence that CO2 does not cause climate change. So why does the temperature rise always actually precede the CO2 rise? So what you see here is actually, if you look at where this, you know, spike is and where it's rising, it's actually a little, or maybe it's more clear to look at where it started. It's actually before CO2 started to rise. So they ask, well, okay, well, how can we say that CO2 causes temperature to rise if the temperature rises first? So we have to look at this historically, and the fact that right now it's anthropogenic climate change, but if we look, there is a natural cycle, and that's governed by our Earth's orbit. So changes in our orbit actually do bring about an initiation of warming and cooling. So the warming that's initiated from this change in the orbit does cause the oceans to release CO2, because as the oceans warm, they become less soluble to gases. And that CO2 then amplifies the warming, so that we get a sort of a positive feedback loop there. And that amplifies the warming, and then that will spread throughout the atmosphere, spreading the warming throughout the planet. So essentially they kind of cause each other in a lot of ways. So when we talk about what's happening now, we're asking, well, what caused it? Well, it's not a natural cycle right now. The cause is not Earth's orbit changing. It is a cause of us burning fossil fuels.